so u sub with trig. When we want to use substitution with our trig functions, are going to be things that look like this: cosine x cubed, or like a sine 2x. Basically, right, anytime you guys have more things going on than just an x, right, this is where we're going to have to use u sub. Okay. Right, all of that. The reason why is if you guys think back to when you were taking the derivative of something, like if I took d dx of sine, actually of 2x, this is a good one. Do you guys remember how you had to take the derivative of the outside, keep the inside the same, and then take the derivative of the inside part? Well, u sub undoes chain rule, and you would have had to take the derivative using chain rule for something like this. Anytime we had something more than just x. So if you were going to take the derivative of sine, does anybody remember what that was? Cosine. Good, cosine. And then we kept the 2x the same, but then we had to times it by 2. Good. So this really became 2 cos 2x. Right? So to undo this chain rule, right, whenever you guys see more things, we're going to have to use substitution, kind of going backwards. Right? Okay, so here's our first example. Oh, yeah, hi guys. Good timing. I recorded just in case. Okay. All right. Court and Kelly, you guys have your agreement sheet. It's like helpful. You have this stuff? Perfect. Court, do you have them? No, no, no.
So that one's going to work out good, so that's going to be 4x.
Right, exactly, Kyle. Okay, so these look way worse than they are. Right? Keep this in mind. Your u, guys, is always going to be like what's with the trig function. Okay, like the x part. So here, right, for your first example, we're going to let u equal this. Okay, x to the 4. Now, when we do du, what would that be? Good, 4x cubed. Yeah. Now let's look to see what's going on here. Right? Make sure it's got to match up. The same way we did regular u substitution. Same idea. We have our 4x cubed. We got our dx. Right? It matches. It's good. Okay? When that happens, we have no corrections, nothing special to do. So what we're going to really integrate is our sine u. Right, we're just going to make everything in terms of u now. All right, let's look at our green sheet. Okay, we take the integration of sine. What's that? Good, negative cos u plus c. Last step is going to be the same thing. We want to not use u, right? Plus u. Put back our x to the 4th in place. So it's going to be negative cosine x to the 4th plus 3. That's it. It seems scary looking, yeah, but not that bad.
Did it turn into x to the 5th? Why did I think of it?
Oh, because, all right, because you're not this is your u. Like when you integrate, think about the u is like a whole variable. Think about it that way. It's like one thing. So you did when you integrated with your trig functions, you never really touched that part. You changed the trig function. Kind of.
Yeah. No,
Okay.
yeah.
That's a good question. Yeah. All right. So let's go through. We have cos 8x. Alright, so first thing, notice as soon as you guys see something with your cosine that's not just an x, that's going to be what your u has to be. So we're going to let u equal 8x. Du should be 8, good, dx, nice. Alright, well let's see, we have our dx, But do we have an 8 somewhere out there? No, right? So this one we have to make a correction. So same thing you guys have been doing, right? Divide both sides by 8. Okay. So we're gonna have a correction of 1/8. So we're gonna make my correction. 1/8. Okay. I'm gonna have to integrate the cosine. I'm gonna put my u in. Now everything's in terms of u. All right. So let's look on our sheet. What's the integration of cosine? Sine, right? That is calculated sine. So we have sine u, and then we're going to multiply by 1/8. So 1/8 sine u plus c, and make sure the last step, put your u back in. So 1/8 sine 8x plus c. That's it. Yeah, and I'm giving those all to you guys. I'm not going to memorize anything. Yeah, so it's the same like steps, like whether you're doing a correction, find u, the du, not too much more difficult. Okay. All right. Do you guys want to try this one? Or do you want one more?
Well, this one has no option.
Yeah. Divide by 2.
Oh, yeah. All ones where you have to put it in for x.
Yeah, I don't understand those ones.
Like the one where you do the.
I think those are coming. No, actually they're not. I don't see those a lot with the trig function, actually. Come on. Yeah.
That'd be hard.
Yeah, that would be hard, because yeah, I don't see that come up. Well, kind of basic, whatever, like maybe the function is more than just an x, and it's always using the x first. So kind of what we did in the very first one, so. You guys should be letting u equal x squared.
Yeah.
Yeah, okay. You guys are still going, keep going. I'm just going to make sure we're all the same stuff here. So we'll see, we have an x, we've got a dx, but we don't have a 2. Did we make a correction of 1/2? Awesome. Our sine.
You get rid of the x and the x?
As long, see how these match up?
Yeah, so it doesn't matter.
Yep, so you don't need it. Yep. So now when you guys do your integration, sine was negative cos. I'm going to my 1/2 through. See? And then put your x squared back in. So negative 1/2 cos x squared. Is that what you guys got? Negative 1/2?
Yeah.
Cos x squared plus c? Great. Good.
Wait, was your correction negative?
Well, isn't the
Integration
of
of
sine
is
negative cosine?
Okay, yeah.
So I just did, like, I just kind of, you're multiplying everything, so I just leaving it separate.
Oh, you're good.
Okay, okay.
You're good. I was just double checking.
That's all right. This one kind of caught me off guard at first. Look at your green sheet. That might help you guys. There's one that is secant, extant. It looks like it's going to be 2 separate things.
But and then the u
What if
will
it
be
was
the same
secant
anyway.
like 1/9 second tan of 1 minus like 2
You guys will see a double U substitution here. Yeah, yeah, that'll definitely be next year. For sure, we're not gonna do it.
So if I take calc 2.
Yeah, we probably see that at the end, maybe. Okay. So, what would you guys let U be? On my side. -1. Yeah, good. So now same thing, you gotta make your correction. We don't have like an extra negative sign. So make sure your correction is gonna be -1. Now at first, this looks way more difficult than it is. It's not as bad as it looks. Okay. Look at your green sheet. Do you guys have something for secant? Yeah, what is it gonna be for? Secant U plus C? Is it squared or anything? Nope, just secant, you're right, good. So when we integrate this, it's gonna be negative secant U plus C, exactly what you said for it. And then just make sure we plug our little minus x back in.
So wouldn't that just be C minus?
C minus.
Secant 1 minus x?
Oh, like put the C first, so C minus? I guess you could, technically. Usually you always see the plus C after. I mean, don't be wrong, Kyle. Kyle, you guys. 2 more to try. Alright, why don't you guys try example 5? You think someone will pull it up. Why is x over? I'll help you with the first step here. Yeah. Remember? Yeah, I moved the bottom up, and remember this really means cos x all cubed, right? It means cos x times cos x times cos x. So when we move it up, just make the exponent negative. Yep. Yeah, so that should be your first one. Rewrite this. I left it like this just to make it easier when we do our U sub part.
That's double chain, right? So is this double reverse chain rule?
No, it's not double chain rule.
Not?
Do your U and du. So it should look a little bit nicer than I think you're thinking. Wait. So what? Well, which part of this looks tougher?
The right one?
This or this? The right part, okay. So let U equal what? What's in the parentheses? Cos x. Whole thing. Well, it's not going to just be one part, because if you had something, if this was like cos like 2x in here, then it would be like a double U sub. We're not going to do that. In here we'll get that part, bless you. Okay. Now let's just see, and maybe we're not sure if this is the right path to go on, but usually we do du. Well, what's the derivative of cosine? Negative sine, good. So negative sine. Yeah. Alright, let's look above. Is anything kind of matching, right? Yeah. Good. We got a sine, we got a dx, that's good, but we don't have a negative, right? So, Noel, you said correction? Yeah. Good, -1, I like that. So we have our -1 correction. Now let's set up our integration. Yeah. The derivative. Think when you were doing the derivative. Well, du.
Wait, the derivative of cosine is just sine.
No, I think it's negative sine.
That's the derivative.
Well, when you guys do your du, du is the derivative. Yep. Yeah.
Oh, you're right.
Right? Make sure that's on the right, right side of your sheet. This is the one I always remember, because like when we talk about Carolyn being like the negative, no offense, Carolyn, the negative, and Sarah was like the positive version, kind of what you guys were saying. That's how I think about it for sure.
I don't know, I was thinking integration.
I know, that's why you thought it's really hard, because it's like, you're going back and forth for a lot of your rules. I mean, it gets tough. Okay, so let's see, we have our correction of -1. All right, we're going to be integrating u to the -3. Okay. So integrate normally first. Okay. Yep, good. So it's u to the -2. Good. Over.
-2.
Good. Okay. Now we're going to times that by -1. So what's going to happen? Positive. Yeah. Good. So it's like u to the -2 over a +2. Let's see. And our last step is going to be, plug it back in. So we got cos x.
Wait 1 second, would you do the -1 times only the u to the -2 over -2, or if you multiply that times c also?
Times c?
Yeah, if you
Oh,
multiply it
no,
times
just the function part. Not anything with c. C just is like at the end. Alright, so we plug cos back in. Cos, right. Yeah, I'm going to leave it like this for 1 second and then have you guys kind of think about what we can do next. How do you guys want to leave it like this? Yeah, bring it down. Good. Yeah, good, Carolyn. Nice. Let's really clean this up. Okay, so we have 2 on the bottom, cos +2x. Right. Now, if you guys didn't see this as an answer, I want you to think about how else you could rewrite this. Yeah, nice, Sean. Good job. Very clever. Right. Do you guys remember 1 over cosine squared is really secant squared? Right? Yeah, nice, Ryan. Good job. So you could do 1/2 secant squared x plus c. That's good. That's great you guys remembered all that stuff. This is kind of a weird one because your u is a trig function. It's a little bit tougher. All right, got one more for you guys.
So is it?
Yeah, I rewrote it. It's kind of weird. If you guys want to, actually you probably don't even need to rewrite this one. If you wanted to rewrite this, you could, but look at your trig function here. Do you guys see anything that's cosecant squared already in your integration part?
Wait,
Yeah, so we have something that this is going to be, which is nice, which is why we don't have to do like a double U sub here. If you did rewrite this and you wanted to, it's fine. You could have did, right, x over 2, like this whole thing would be squared, right, if you wanted to rewrite it. We don't have to because we have something when we take the integration of this. Like if on your green sheet it's telling you that cosecant squared is something. Okay, yeah. So why don't you guys do it? What do you want to let you here? Thank you. You got it. Good. Two. Great. What's D gonna be? No, I'll read it. Just a half. Good job. It's just a half, right? Isn't this the same thing? Right. Since the derivative is just 1/2. All right. Do we have a extra like 1/2 anywhere? No. So times by 2. Good job. So here's your correction. All right. So let's see. We got our correction of 2. All right. We're going to integrate cosecant squared 1/2. Oh, no, sorry, 1/2, sorry, you. Gosh.
What do you think, Ryan? Negative 15?
Good job.
Ryan's saying this is really negative cosine u. Right, plus b. Now, just make sure, let's simplify this part a little bit. Make it -2 cosine, and then let's put our u back in, which was x over 2. What do you guys think? Not too terrible? Once you kind of know your u sub steps, a lot of them are the same. But use your green sheets for help. So it's like a nice kind of guide when you guys are going through it. Alright, so for homework, why don't you try on page 307. If you guys want to take like a picture of it and like start it now, you can. 47 to 39. Oh, 59, thank you. God, I can't even see that part. I'm going to read those the other way. 59. Okay. No, I tried to recover.